With networks theory. Today we'll be resuming back with magnetic circuit. So in magnetic circuit, what all things we'll be looking at series connection. In that we'll be looking at aiding and opposing connections. Then we will see one of the special cases. Then we'll further move into parallel again, aiding and opposing case in that too. Then finally we would go ahead and we'll see transformer coupling, same aiding and opposing. Then we'll see coupling coefficient. Then we'll see how do we approach the problems, and with that we will end up this particular module. Fine, so let's get started. Very simple lesson. The first thing is series connection. So whenever dot is entering, dot through dot, either the current enters or leaves. At that time we'll call it as aiding connection. At that point L equivalent is L1 plus L2 plus 2L. When it is opposing, it is L equivalent L1 plus L2 minus 2L. So basically in series connection it is L is L1 plus L2 plus or minus 2M, plus is for aiding, and minus is for opposing. Similarly for a parallel connection it is L1 L2 minus M square upon L1 plus L2 plus or minus 2M. Now plus is for opposing and minus is for aiding in parallel combination. Fine. Now one of the special cases in series combination was, let's say there is one of the wires coming out between A and B. In that case what will happen is it is nothing but L plus M and minus M. Similarly when it's opposing, in that case it will be L1 minus M and L1 L2 minus M. So if here it is minus, M is going to be carrying the opposite sign. Fine. Now let's move ahead and see what is the energy stored. So energy stored is nothing but half L1 square plus half L2 square, half Li1 square plus half L2 I2 square plus M I1 I2. Now transformer coupling. In transformer coupling again there will be a aiding case and opposing case. What do you mean by aiding case in a transformer? If through one current enters and through other current leaves, then it is a aiding case. Okay. In that case the equivalent is basically L minus M. In aiding, L minus M, L minus M. Fine. And in opposing it is L plus M minus M, L plus M. Okay, this M will always be opposing. So one of the confusion which always sustain between transformer coupling and the special series case which we saw. So just want to make clear this thing here, that in transformer with a special case with one tapping, you will have L1 plus M minus M and L2 plus M. Whereas for transformer it is delta. It will be for aiding, it will be L1 minus M, L1 minus M. Okay. Now one thing to note is, for transformer V1 upon V2 is equals to I2 upon I1 equals to N1 upon N2. Okay, with this you will be able to solve most of the question. Then Z1 upon Z2 is nothing but N1 upon N2 का whole square. With this basic equations you will be able to solve almost all the questions. Now let's understand what is a coupling coefficient. Coupling coefficient case M upon root L1 L2. M is, you know, right, mutual inductance, and L1 and L2 are self inductances. Now what if in question sometimes it is given that it is at resonance? In that case you have to understand that XC is equals to XL. Okay, that will help you. Then to calculate ABCD parameters you will be using, as I told, the standard equations, and once you get one of the parameters ABCD, or let's say anything for that matter, rest of the parameters you can find calculating using the same ones. Correct. Now what if nothing tries? If they ask something I1 of t, I2 of t, and you are getting nothing in mind, in that case your ब्रह्मास्त्र आपका इकलौता औजार होगा लाप्लास. भैया लाप्लास स्टार्ट कर दो, दोनों में लाप्लास अप्लाई कर दो, I1 to t, I2 to j, जो निकालना है आराम से निकाल दो, कोई टेंशन वाली बात नहीं है. ठीक है, तो बहुत ही छोटा प्यारा लेसन था. आपको इसमें सीरीज़ कनेक्शन, एडिंग ऑपोजिंग पता होना है, स्पेशल केस, फिर पैरेलल में ऑपोजिंग और एडिंग पता होना चाहिए, फॉर्मूलाज में क्या डिफरेंस आएगा. देन आपको ट्रांसफॉर्मर कपलिंग पता होना चाहिए, ऑपोजिंग एडिंग, व्हाट इज़ कपलिंग कोएफिशिएंट, फिर प्रॉब्लम्स को कैसे सॉल्व किया जाता है, व्हाट इज़ द स्टैंडर्ड अप्रोच. अगर कुछ स्ट्राइक नहीं होता है तो वी मूव टू लाप्लास, एंड दैट्स ऑल. तो इतना ही सब कुछ है इस चैप्टर में. विद दिस वी कैन कंक्लूड दिस पर्टिकुलर चैप्टर.